This is a practice problem for energy. When I do problems, I always write the equations for energy over here. This helps me to be confident with the equations and to memorize them. So potential energy equals mass times gravity times height. Kinetic energy equals 1/2 mass times velocity squared. And energy and work are very closely related. So I can write the work equations down here. Sometimes we have springs in the question. I can write those as well. But I typically just start off here, and then I read the question and see what it's asking. A spring. Okay, so I know I need to know springs here. A spring with a spring constant of, so the spring constant is K, 242 newtons per meter, is stretched by 9 centimeters. So the distance, which we're going to write as X, and I'll explain that in a minute, is 9 centimeters. But we can't use 9 centimeters. We have to know our distance in meters. So centimeters on top, so I put centimeters on the bottom so they cancel out. I go into meters. There are 100 centimeters in 1 meter. So therefore, it's 0.09 meters. Okay? All right, so let's read it again. A spring with a spring constant of 242 newtons per meter, got it, is stretched by 9 centimeters, got it. What is the elastic potential energy? So I want to know the potential energy elastic. Okay? A lot of times you write that as an S because it's a spring. Of the stretch spring. So my equation for potential energy of a spring, or elastic potential energy, is 1/2 kx squared, where x is the distance the spring is stretched or possibly compressed. K is the spring constant. So this is a straightforward question. I'm just going to plug that right in here. So I write the equation again. This helps me to become confident with it. It also helps me to memorize it. And I just plug in the numbers. Potential energy of the spring equals 1/2 times K, which is 242, times x squared, so it's 0.09. That's squared, so the potential energy of the spring equals, get our calculator, 0.09 at squared, so I'm just going to multiply it by itself again. And then I'm going to times that by 242. And I multiply that by 1/2, which gives me 0.98. And energy is measured in joules. There you go. The answers are typically multiple choice. So because of possible rounding, the answer might be a little bit different. It might be 1, it might be 0.96. So whatever multiple choice answer is closest to this, that's what you choose.